Welcome back to iOS Expert. In the last video, I showed you Roman numerals and its source files. Here's how to start unit testing. The first step is to create a unit testing target. This is a container for all the unit tests associated with a particular target, in this case the Roman numerals app. Click the Roman numerals project in the Project Navigator. Click File, New, Target. Scroll down to the Test section and double-click Unit Testing Bundle. The convention on iOS is for the unit test target to be the name of the app, plus the word tests. The suggested name Roman numerals tests is therefore good. Click Finish. Note the new target, Roman numerals tests. Xcode has helpfully created a group, Roman numerals tests, to hold unit test files for this target. Xcode also creates a file with the unit test, Roman numerals tests.swift. One goal of unit testing during app development is to achieve high unit test coverage. By this I mean the percentage of lines of code in the app that are exercised by unit tests. 100% would be ideal, but is never possible. Certain code, for example a fatal error in the event of an unrecoverable error, just can't be tested. I have found, both at work and in coding challenges, that 85% unit test coverage of a UIKit app is considered strong. For reasons I will explain in another video, the acceptable percentage for a SwiftUI app is somewhat lower. Another goal of unit testing during app development is to verify correct behavior of code. This goal is complementary to that of high unit test coverage, because an app whose behavior is exhaustively verified tends to have high unit test coverage. Likewise, any particular code that is untouched by unit tests necessarily lacks behavior verification. The unit test file that Xcode created, Roman numerals tests, doesn't directly call any code in Roman numerals, so there is no behavior verification. But the unit test coverage at this point is actually greater than 0 because running any unit tests causes your app to launch, which causes your app delegate and scene delegate to run. I've got good news, bad news, and good news about unit test coverage. The good news is that Xcode can report unit test coverage both in every file in your app and in the entire app. The bad news is that before version 15, Xcode did not report these percentages by default. The good news is that in version 15 of Xcode, unit test coverage is automatic. Unit tests live in subclasses of a class called XCTestCase. Roman numerals tests is no exception. Every XCTestCase subclass has a handy diamond-shaped button that runs all unit tests in that subclass. Click the button to see how unit test coverage looks for the app. The default unit tests, such as they are, run. Note that the button for the subclass is green, meaning that all tests within the subclass passed. Time to see coverage. Click the Report Navigator. Click Coverage. Expand Roman numerals.app by clicking its chevron. Note that Xcode reports unit test coverage for the whole app, as well as for all the files within it. Individual source files have coverage data for every line. Here is scenedelegate.swift. Xcode shows in green which functions ran and lines ran during the previous unit test run. Will connect to ran one time. Xcode shows in red which functions and lines did not run during the previous unit test run. Observe that scene did disconnect, scene will resign active, and scene did enter background did not run. You might recall from a minute ago that unit test coverage for Roman numerals is already surprisingly high, about 41%. Scene delegate provides a clue as to why. Running a unit test caused this function will connect to run. Most of the lines in the function ran one time, including a line that initializes a converter VC, the biggest object in terms of number of lines in the app. The runtime calls converter VC's load view function, which initializes a converter view, another large object. These calls end up exercising a large proportion of the app's code, almost half, with just a boilerplate unit test. Scene delegate also provides an explanation for why 100% unit test coverage is often impossible to achieve. This fatal error line doesn't run during unit tests, reducing coverage. But this line can't run, even using non-boilerplate unit tests, because if this line did run, the unit test runner would stop running. Time to start the real unit tests. Where to start? I propose converter, which has the functions that convert between decimal and Roman. Converter is easy to test because its two functions are, in testing parlance, pure. That is, these functions have no dependencies other than their arguments, and they have no side effects, undesirable or otherwise. Traditionally, in the iOS development community, most unit test files in a unit test target correspond to Swift files in the target being tested. This has implications for naming and placement of unit test files. Converter.swift is in the models group of the Roman numerals group, so create a models group in the Roman numerals tests group. In this group, create a file of type unit test case class. Click Next. Name the file convertertests.swift. Click Next. Xcode is offering to create this file in the models group and folder, which is correct. Ensure that the file is a member of the Roman numerals tests target, not the Roman numerals target. Click Create. Convertertests.swift will soon have real unit tests, but before you continue, delete the boilerplate Roman numerals tests.swift file. This file has served us well, but the real unit tests will go in more focused files like convertertests.swift. Back to that file. Converter tests is an XC test case subclass that will eventually have two functions for testing converters to functions. Delete everything between the opening and closing curly braces of converter tests. I'll explain the possible utility of that boilerplate later. A common practice in iOS development is to make one test function for every internal or public function in the type being tested. The names of the test functions can't be identical to the functions being tested because the test runner requires that the first word of every test function name be test. So the common practice is to prepend the word test to the names of functions being tested, changing capitalization to preserve camel case. Putting these conventions into practice, create two functions in converter tests, one called test convert from decimal to Roman, and the other called test convert from Roman to decimal. No arguments. Note the capital C in convert. A suite of unit tests consists of assertions or truth statements about the behavior of code being tested. So tests of the function convert from decimal to Roman consist of assertions about the outputs of that function given various inputs. Given the Objective-C heritage of Apple's unit testing framework, XCTest, these assert functions all start with a three-letter prefix XCT. Here are the most commonly used assert functions. All are in XCTest. I will introduce these functions in context, but one comment. Observe that XCT assert and xetassert_true have identical semantics. Each is just an alias for the other. I prefer xetassert because of the reduction in typing and visual clutter. But many developers prefer xetassert_true, perhaps because of its symmetry with xetassert_false. The temptation is strong for me to read this entire slide aloud, but I am aware that reading aloud is bad presentation practice. I will instead therefore whistle part of the traditional English melody Greensleeves as you gaze upon these functions. Time to write tests for converter. That enum is, in testing parlance, the system under test, the particular thing being tested by certain unit tests. System under test is commonly abbreviated SUT or SUT. When I'm writing unit tests, I like to have the SUT file showing an Xcode next to the unit tests so that I see the signatures of functions to test as well as what lines have been covered by unit tests. Here's how to do that. Show the project navigator. Hold down the Option key and then click the SUT file, in this case converter.swift. Note that this file is completely untested for now. As you can see, the first function from the SUT, convert from decimal to Roman, starts with parameter checking. The checks are for whether the string passed in represents a valid integer and whether that integer is in the valid range of 1 to 4,999. The function returns nil if a check fails. Let's start by verifying that these checks work as expected. Add this initialization and these assertions to the first test function. For now, close converter.swift to save space. This is snippet 1. Like other snippets for this crash course, this snippet is in the iOS Expert repo, in this case in the unit testing folder. Note the build error. Converter is internal to Roman numerals, so it's not immediately visible in another target, Roman numerals tests. Put this line above the other import in the file, snippet 2. This special import makes internal symbols from Roman numerals, including converter and its functions, accessible in unit tests. Every unit test file that tests internal symbols from another target needs a line like this. I'll just include this line in future snippets without mentioning it again. Run the unit test by clicking the diamond to the left side of its function. The error checking portion of the function is now green, meaning that it is properly unit tested. Now that invalid inputs are accounted for, you might think you just need to test one valid input. The function should convert the decimal number 1 to the Roman numeral I. Add this assertion to the test function, snippet 3. Run the unit test. This one assertion does not exhaustively exercise the function. With this input, only these two lines are being exercised. But there is a set of assertions that do exhaustively exercise the function. While scripting this section of iOS Expert, I built up this set using experimentation and examination of the function itself. In the interest of time, I won't take you through every step of building this set, but here it is. Snippet 4. Run the unit test. The function is now entirely green, a synonym I will use going forward for tested. The second function from the SOT, convert from Roman to decimal, has different parameter checking. The first check rejects any input string that has characters that are invalid Roman numerals. The second check rejects any input that can't round trip from Roman numerals to decimal to the original Roman numerals. An example would be the Roman numerals I, which convert to 4, which converts to IV, which are different from I. Add this initialization and these assertions to the second test function, snippet 5. Run this test function. The parameter checking is now green. The function's happy path can be tested with just one equality assertion. Add this line, snippet 6. Run the test function. The whole function is now green. Here is how to run all tests in a unit test target. Show the navigator. Click the test navigator. Click the diamond button next to Roman numerals tests. Unit test coverage has increased to 72%. This concludes my short introduction to unit testing iOS code. In the next section of the course, I'll show you how to take testing to the next level with custom app and scene delegates.